Alright, so today we're going to talk about transforming the probability distributions, okay? So let's start at 6.2. So we're going to talk about the first part of this big ideas index card I got right here. We're going to talk about the adding the same constant to each value, in which case that'll take our shape, which will stay the same. Our center we would add C, and our variability stays the same. And we'll talk about that and we'll see that, okay? We'll do an example on that. So again, adding isn't going to change the shape or the center too much, but you're just going to have to add that value that you added, C, to the center, okay? And the variability will stay the same. When we multiply the same constant to each value, we'll see that the shape stays the same still. Our center, instead of adding, we'll be multiplying by that C, that constant value, as well as the variability will be multiplying by that constant. So in other words, the standard deviation, right? So with this, our standard deviation down here, again, that's how it's notated, SD, which is the same thing as lowercase sigma, and we're taking the constant times that standard deviation, and then same thing for the variance overall. Is how this plays out. With you have that squared, okay, so it's going to apply to both a constant and standard deviation value. The big thing we want to talk about here today, though, is understanding what the adding and the multiplying the same constant to these values does. Let's look into this. So dealing with our example from yesterday when we talked about drawing out a strip of paper to see how much you get paid per hour and whatnot. We had the total values of $1, $5, $7, and so forth, all the way to $25. And our probabilities, these are the probabilities we had from our example from yesterday as well. So then what was our mean for this? So again, if you don't have the TI Inspire, don't worry about that. Let's just use good old Statplet, okay? So we'll just name these X, and the data values we had were 1, 5, 7, 10, 15, and 25. Okay? Just click Begin Analysis, and right down here we can see our mean is 10.5, and our standard deviation is 8.5264. Okay? 5264, and the mean was 10.5. So when we have these values, what we want to see is what happens if we add $10 per hour to all employees. So I want to see what's going to happen to our mean, our standard deviation, and our probability. We want to talk about that as well. So again, our old wages that we started out with were up here up top. So we just add to each of these. So we're going to take 11, 15, I'll grab my 5, you get everyone here, 5, and then we're going to go 17, 20, 25, and 35. All right, and so what do you think it's going to do to our mean? We already talked about the big ideas, right? So for our mean, it's saying that if we add up here, if we add, then the shape stays the same, but the center we're going to add 10, or add C, so we should add 10 in this case, right? So add C, our constant value. So let's look and see what happens. So if we're going to do that, let's go up here. So again, our mean was 10.5, so we'll reset everything. Again, we'll just call this X for the time being, and we'll put in those values we had. We had 11, and 15, 17, and 20, and 25, and 35. Okay, so we added $10 values. We get analysis, and then look at that. Our mean jumped from 10.5 to 20.5. And our standard deviation do anything? No, our standard deviation stayed the same. All right, so we know that our mean jumped up to 20.5 because we added 10 to it, just like the big ideas told us. And our standard deviation did not change. They stay the same. Now, what happened with our probabilities? Anything change our probabilities? Does that change the probability of you getting anything? No, that doesn't change the probabilities of getting anything. The probabilities stay the same. So we're still going to have the same probabilities because it didn't affect anything as far as how you draw the wages out. It didn't change the amount of paper slips we had. It didn't change the order in which paper slips were arranged. Nothing like that. Again, we just added to the actual new wage. So with these, again, your probabilities stay the same. It's not going to change. However, though, our mean went up by 10, and our standard deviation stayed the same. Okay? So let's do what we talked about a second ago as well. Let's see what happens when we multiply. So in this case, they're wanting us to double the wage of all employees. So again, we're going to take the initial values and double them. So we got 2, 10, 14, 20, 30, and 50. So let's see what happens when we change these values. So we want to see what's going to happen to our mean, what happens to our standard deviation. Now initially our original mean was 10.5. So let's see what happens. Reset everything. We'll leave this top as X. And our data that we're going to put in is what we just came up with. So 2, 10, 14, 20, 30, and 50. All right, and when we do that, look at that, the mean doubled. It went from 10.5 and you multiply it by 2, it went up to 21. Now what happened to our standard deviation? Looks like our standard deviation doubled as well. So exactly like the big ideas told us what was going to happen, that did actually happen. So we got 17.0529. All right, and we had 21. Now what happened to our probabilities? Are our probabilities going to change? No, the probability is going to stay the same. Probably stay the same. Not even going to write them all out again. We know they just stay the same. Stay the same. Okay, now the big thing we want to look at is our mean, which our mean doubled. So we took our mean doubled, and then our standard deviation doubled. Standard deviation doubled as well, because we doubled all of our values up here, okay? So we took these values and we times 2 on all these values. Our probabilities stay the same on that. That's what the big thing I really want you to take away from this, okay? So again, with adding, shape stays the same. Your center, your mean value is going to stay the same. Oh, I'm sorry, you're going to add the constant, I apologize. You add the constant value that you added to it. And the variability, your standard deviation, will stay the same as well. When you multiply, the shape is still going to stay the same. The center, you're going to multiply by that new C value. And the same thing you're going to do to your standard deviation. You're going to multiply it times that C value, in which case, in our example, we doubled everything. So that doubled our center and it doubled our standard deviation. And for the adding, we added 10, so our C value was 10 in each one of those cases. That's the big thing we'll take away from this. Also, that the shape stayed the same. It didn't affect the shape in any form or fashion. All it did was simply just make the numbers look bigger. It wasn't anything to do with the shape, okay? So, again, a short little lesson here. Just really wanted you to grasp that understanding about transforming probability distributions. Hope you learned a little bit of something today, and I'll see you next time.